I'll be helping you guys review today is cost minimizing input combination and productive efficiency. It's a mouthful, but by the end, you guys, I will minimize your minimize your understanding and make you more efficient with this topic. So today, very nice. So what we're going to go over is we're going to look back. We're in the micro section of economics. This is, as well as go over the cost minimization rule with a couple of other examples, profit maximization, as well as 2 real-world examples of how this is used. So first off, this is module 72 in our textbooks that we all read. So pages 715 to 719 if you want additional information on this whole topic. And so looking at the cost minimization rule, the textbook definition is that that a business wants to employ factors so that the marginal product per dollar spent on each factor is the same. So what does that mean? You want this formula right here to be equal. You want your marginal product of labor to equal the amount of money you're spending on your labor, just as you want the marginal product of capital to be equal to the amount of money you're spending on capital. And so this example right here is going to kind of walk you through this. So our example here is one that we saw when we kind of discussed this unit, but in essence you're given 4 numbers and you want to match up the numbers that are related to capital and then that are related to labor. And so looking at this equation again, you have your specific numbers matched up for labor. So for labor you have the $600 is the marginal product of the last worker, and then $150 is how much you're paying that most recent worker. And then so for capital, you have the last unit of capital producing $1,200, that's the marginal product, and then you're spending $300 on that. And so then when you divide them out, they each would equal 4. So in this case, this business is minimizing its costs because these 2 are equal. And so if they weren't equal, and I apologize for my animations, they are a little off as I converted this to Google Slides. But if they weren't equal, for example, like in this here, 5 doesn't equal 2. So you would have a situation where they're not minimizing their costs. And so in order to minimize your costs, you want to have more labor in this case because you have a greater number here. In order to make yourself efficient, you would want to put more spending towards labor. Because just imagine, if you now put $400 toward labor and still got 1,000 output, your fraction would be 1,000 divided by 400, which is smaller than 5. And even though you're not 100% efficient, you're still more efficient than what you were prior to spending more money. And so that's kind of what you want to do in this scenario. And we saw a lot of this in our factor markets packet, where we had to we got 3 different situations, and we had to decide how to better spend our money. And so then going to the profit maximizing rule, use the same formula, but the key difference is that you want it to equal 1. If this equals 1, then you're maximizing your total profit as well as minimizing your costs.
Can you go back 1 second?
Sure.
It's almost the same formula, but notice this is marginal revenue cost.
Yes,
Not margin.
Correct. So one minor difference, but the same structure of the formula overall, and you want this to equal 1. That's how you maximize your profit. And then going through a similar example here, just quickly highlighting 150 divided by 150, 200 divided by 200, both equal 1, and this allows you to maximize your profit as well as minimize your cost. So looking at this in the real world, 2 different applications of this is the common situation that you have at Walmart or any other retail store. The idea of cashiers versus self-checkout. Is the company going to spend more on workers, or are they going to spend more on a self-checkout station, such as that would be like capital, whereas workers are, or cashiers are like labor. So they have that debate as how to minimize their cost and be most efficient to make that profit. Another example would be, in the factories where we're producing cars. Is it more efficient to have machines or robots do the assembling of cars, or is it better to have a human doing it? Those are the kind of debates to maximize the profit and to minimize the cost. And so these 2 links here take you to examples that we have done in class. This first link takes you to the factor markets packet, and specifically you want to reference page 10, as that covers this entire topic, as well as provides you with a variety of examples. The second link takes you to a free response problem that covers this topic, back from 2006. You just have to scroll down to number 3 in this one. So you guys have any questions on anything relating to minimizing cost and maximizing profit?